Okay, we're dealing with successive ionisation of a magnesium atom, removing the electrons, so we ought to start by knowing what the electron arrangement is in magnesium. So we'll write that down. Atomic number's 12, so we've got 12 electrons arranged in the atom. Innermost shell is going to contain 2 electrons, and then the second shell has 8 electrons, that's 2s2, 2p6. And the remaining 2 electrons will be in shell 3. There we go. When we ionise, we remove electrons from the outer shell, working our way in. So we can write underneath each ionisation which electron we're removing, starting with the 3s2 electron and working backwards in towards the nucleus. Notice that we're only doing 10 ionisations. We don't actually remove all the electrons from this magnesium atom. And notice also when we go from shell 3 to shell 2, and then when we go out of shell 2, we'd expect a big jump in ionisation energy, and that's reflected in the data. The question was which electrons were removed from S subshells, and by writing the electron arrangements underneath each electron that's being removed, we can pick out which ones came from the S subshells. That's the first and second from 3s, and then the 9th and 10th from 2s. Now we're asked to write an equation for the third ionisation of magnesium. That's the one that's going to result in a 3+ ion in the gaseous state. Always the gaseous state, because that's what the definition of ionisation energy says. So we've removed an electron to get Mg3+. That means we must have started with Mg2+, and there's our finished equation.